All right, guys, welcome to Unit 2, Quiz 4. On this quiz, basically what we're doing is there's not going to be an FRQ this time around. We're just going to be seeing how well you can distinguish the different types of integrals that we've learned and know how to tell when to use which strategy. I think that this little paper that I gave out back on, gosh, what lesson was that? I think it was 2.12. This will come in kind of handy in knowing when to use which strategy. So I would encourage you guys to have that out. I won't be pulling the sheet up while I work, but I will be talking about the sheet and as I work on these problems and kind of showing you the criteria I'm looking at to make my decisions. So a lot of the decisions go into, a lot of this test is based on not just getting the answer, but knowing which strategy to use so that you can get the answer, okay? Because there's a lot of strategies that we've learned, and a lot of these problems look very similar. All right, so what I want you guys to notice is that since the denominator's power is 1 more than the numerator, now let me show you what I mean. The denominator's power is 1 more than the numerator's power. We are going to do U substitution. Okay? U substitution is going to work there because we have to take the derivative and it will cause that 5 to go down 1. And then that'll cancel out the x to the 4th. So that's kind of your hint there. So let's go. U equals 4x to the 5th plus 3. The derivative of u with respect to x is equal to 20x to the 4th. Du over 20x to the 4th is equal to dx. Rewriting our integral. We have that. All right. Now, anytime you have 1 over a letter to a power other than 1, since this is not 1, we will rewrite like this. You'll just bring it up the top and change the power to a negative. Now notice I said since it's not equal to 1. If this power was a 1, then what we would have on our hands at this point is an ln problem. But this is not an ln problem since that power on the bottom is not equal to 1. So at this point we're just going to do the power rule. That's where you would add 1 to the power and divide by that value. Next, I would probably put that 1 over 4 like that, and I'd probably put that u to the 4th in the bottom so it's a positive power now. And then finally, I would replace the u to the 4th, sorry, the u with what it was originally, 4x to the 5th plus 3. And we got a 4th power there now. And that's it. Okay, so that is number 1. Couple of things that we noticed was since this power was 1 more than this, it was a u sub from the get-go. Second thing we noticed was that since this was not a 1, we were going to go with the power rule approach rather than the ln approach. Let's take a look at another one here. No u sub on this one. But I do notice that this one looks a lot like what we had a second ago in the last one. Since this is not equal to 1, we're just going to bring it up to the numerator, make it a negative, and then we can just do the power rule, where we add 1 to that power, and we divide by that value. Now these negatives cancel, so I'm left with 5. this x can go to the bottom since it's got a -1 exponent, and there would be our final answer. So the only thing we want to be aware of here is that since this was not equal to 1, we did the power rule. If it was equal to 1, we would do the ln rule. Now, taking a look at this, this is one you just kind of have to recognize the pattern with. This looks an awful lot like one of our integrals that we learned. It's one that looked like this. And what that is an arcsecant. Okay, but we got to be aware that in this pattern, there's a couple of things that need to hold true. We can't have this on the top. We're supposed to have a 1. Another thing that's a little bit off is this is not supposed to be an x to the 8th power. Oops. It's supposed to be something squared. And so what we have is more than just an x squared there. And when that happens, what we need to do is we need to do use substitution, where we replace this piece here with something squared instead. Okay, so what to the 2nd power would give me x to the 8th? The answer is x to the 4th. And that's what my u is going to be. My u is going to be the x to the 4th. The derivative of u with respect to x is 4x cubed. And then finally getting the dx by itself, we have that. Doing our u substitution then, we have 4x cubed over u times the square root of u squared minus 25, and then du over 4x cubed. And now these cancel out, and now this looks a lot more like an arctangent, or I'm sorry, an arcsecant should look. Okay, so we're ready to do it. 1 over a. A is the square root of this number. Arcsecant, absolute value of u over a plus c. And then finally, we want to replace the u with what u was originally. And that was 4x to the 3rd over 5. Okay, so for this one, since we have a quadratic, that means the highest power is a 2. A quadratic trinomial, that means there's 3 terms. We will complete the square. So that's the strategy for that one. So to complete the square, what we do is we're going to create a new number here. And after we create that new number, we're also going to subtract that same value. Having a technical difficulty there. There we go. All right, how do you get the new number? You take half of this number, which is -7. You square it, which is 49, and that's what you're going to put right there, and then you'll also put it here. The next step is to factor these ones, and there's a shortcut. That's what we call a perfect square trinomial. When you factor those, they always end up looking like this. The only thing you have to figure out is what number goes here, and that number will always be half of this middle number here, which is -7. These can be combined to make 1. So now that I've changed this, I've completed the square here, I'm basically going to replace this denominator with that value. So now I have 8 over x minus 7 squared plus 1. Another thing I'm going to do is I'm going to take that 8 and I'm going to kick it out to the front. All right. From here on out, what we're going to do is we're going to do u substitution. The u is the part that's in parentheses. The derivative of u with respect to x is 1. And getting dx by itself, we find out that dx is simply equal to du, which means I can rewrite this in the following way. And from here, we should see that this is an arctangent pattern. Okay, arctangent looks like the following. You have 1 over a. A is the square root of this number, which is 1, times the square root of that number over a plus c. Now, I really don't need this 1 over 1 in the front, so I can get rid of that, just 1. We don't need this 1 on the bottom either, because it's just 1. But the u I do need to put back. The u is x minus 7. And so there's my final answer for number 4. Let's go ahead and move on to our next problem here. This one is one of those things that just got to stand out to you. Hopefully you're recognizing this pattern. This is one of our things that we've learned. And that one is arcsine. All right, so for this one we have arcsine is going to be x over a, which is the square root of that number, plus c. Doesn't get any better than that. That's probably one of the easiest ones there. Pretty sweet. Doesn't mean arcsine will always be the easiest one. I'm just saying that one happened to turn out pretty simple. All right, let's go ahead and take a look at number 6. All right. So for this one, since the power on top is greater than the power on bottom, the power on top is greater than the power on the bottom, we're going to go with the long division approach. Okay? So how the long division approach works is we're going to take this whole thing here, put it on the inside, then we take this whole thing here and put it on the outside, and then we get to do some pre-algebra that we haven't done in a while. We ask ourselves, how many times does x go into x cubed? And the answer is x squared times. So we'll put that here. Next, I'm going to multiply that times both of those and put the result underneath. And we get x cubed plus 2x. Next, we'll subtract. These go away. These combine. That should be a square. Those combine to make 3x squared. And then we bring down the rest and repeat the process. So what would I multiply x by to get 3x squared? That would be 3x. So I'm going to take that and multiply that times both of those numbers and put it underneath. So that would be 3x squared plus 6x. And once again, we're going to subtract. Once again, the first one cancels. These should combine together to give us a new value, and then you bring down the last number, and we have 3. All right, next we're going to ask ourselves, what do I multiply x by to get negative 2x? And the answer is negative 2. I will multiply that times both of those and put it underneath, and I get negative 2x minus 4. And then changing the signs on the bottom because of the subtraction, these go away, and then we're left with 7. All right. So the long division's over with. The integration is not. What we've just done then is I've divided the top polynomial by the bottom polynomial. And as a result, we're going to have this as the new result in the integral. And then we have our remainder over our divisor. So step one is to do that long division. So applying the integral here, you would get x cubed over 3. Applying the integral here, you would get 3x squared over 2. And then applying the integral here, you would get minus 2x. Applying the integral here, now you might want to do that separately. One way that you could do this is you could do the u sub method. That is not the method I'm going to go with. I'm going to go with the shortcut method that I taught you guys earlier, where you do this number over this number, ln absolute value bottom. Okay, so that's what that one would be. Let's see if I can drag that. Nope, it disappeared on me. Where did that go? We can just put that right there. We're going to make that a plus. And we probably don't need to have this written as 7 over 1. We could probably just have a plain old 7 there. But that would be it. Okay, so that's the long division method. Now, since this is a 1, we have an ln. Okay, so we really don't want the 2 or the negative in there though, but that's okay. We could take both of those and scoot those out to the front because they're just constants. And this part here is simply ln. Okay. And then finally we got this fun guy here. There's only one strategy left. This one's probably the hardest to recognize because of a few reasons. Some of you guys might be looking at this and thinking, oh, well, Mr. Bailey, I see that this power is 1 more than this, so you might be thinking u substitution. You wouldn't be entirely wrong, but you would find that if you started with u sub here, the 7 is going to end up being a problem. And because of that, what this is a splitting the numerator problem. That's another integration strategy. And what that means is we're going to write this as 2 separate integrals. One where the x is being divided by the denominator, and another one where the 7 is being divided by the denominator. And we're just going to treat these as 2 separate integrals, and we're going to integrate each one. Okay? Now, let's go ahead and start with this guy. Now, it would not be a bad thing for you to recognize that this power is 1 more than this power, and therefore what we would do with that one is we would do a u sub. So I'm going to do that over here. Your u would be the 1 minus x squared. Notice these x's go away, and the negative 2 can come out to the front. And so we would have the following. Now, another thing is that we can rewrite that square root as a half power, because that's what square roots are. And since this is not a 1, then we're going to treat this like a power rule problem. And with those, if it's in the denominator, we move it up to the numerator and make it negative. Now we're ready to integrate. So we add 1 to this power, and that gives us a half. And instead of dividing by a half, we'll multiply by the reciprocal. These cancel, and I'm left with negative u to the half power, and that's it. And my u was, in case you forgot, 1 minus x squared. And so there's my integral for this first piece. Negative parentheses 1 minus x squared to the half power. Now we're going to do this one. I think we'll find that one's not quite as icky. For that one, if we just kick that 7 out to the front, then what we have here is a pretty classic looking arc sine problem. So we have arc sine of x over a is 1 because that's just the square root of this number, and then plus c. We don't really need the 1 in the denominator, and so we'll just put as x. And then the plus is still there, so I'll bring that down. And in this case, we're done. So for this one, this is a splitting the numerator problem, and basically what it results in being is just 2 separate integrals, so it becomes like 2 problems in one. So for that one, the trick is in recognizing it and then realizing it's kind of double the work. But anyway, that's that, and hopefully that was helpful, and we'll see you guys in class.